Welcome to Askprep, your trusted companion for NEET and JEE preparation. Today we will study about a very important topic of chemistry, which is molecular orbital theory, specifically focusing on bond order and stability. To begin with, we need to understand the very foundation of molecular orbital theory. Atoms form molecules by bonding with one another. The way these bonds are formed, and how they influence the properties of the molecule, can be explained using molecular orbitals. But what exactly is a molecular orbital? When atoms come together to form a molecule, their atomic orbitals interact and combine to form new orbitals that belong to the molecule as a whole. These are the molecular orbitals, and they are responsible for holding the atoms together in the molecule. Molecular orbital theory is based on the concept that atomic orbitals combine to form molecular orbitals, which are spread over the entire molecule. Unlike the simpler valence bond theory, which treats bonds as localized between atoms, molecular orbital theory gives a more comprehensive picture of bonding, particularly for molecules that involve multiple atoms or those that don't fit neatly into the valence bond model. When we combine atomic orbitals from two atoms, they can form two types of molecular orbitals: bonding orbitals and antibonding orbitals. Bonding orbitals are the result of constructive interference of atomic orbitals, where the wave functions combine to increase electron density between the nuclei. This increased electron density between the atoms helps hold them together. Antibonding orbitals, on the other hand, arise from destructive interference, where the wave functions cancel out in the region between the nuclei, creating a higher energy state that tends to destabilize the molecule. Now, let's talk about bond order, an important concept in molecular orbital theory. Bond order is a measure of the strength of the bond between two atoms in a molecule. It is essentially the difference between the number of electrons in bonding molecular orbitals and the number of electrons in antibonding molecular orbitals. The bond order can give us an idea of the stability of the molecule and how strong the bond between the atoms is. A simple way to understand bond order is by looking at the number of bonding and antibonding electrons in a molecule. If the bonding electrons outweigh the antibonding electrons, the molecule will have a positive bond order, indicating a stable bond. Conversely, if there are more antibonding electrons, the bond order will be negative, indicating instability, and the molecule might not even exist. For instance, a bond order of 1 means a single bond, bond order 2 means a double bond, and so on. Bond order is closely tied to the stability of a molecule. The higher the bond order, the more stable the molecule is. This is because higher bond orders indicate a greater net electron density in bonding orbitals, resulting in stronger bonds. On the other hand, molecules with low or zero bond orders are less stable and may even be unstable under normal conditions. Now, let's understand how to calculate bond order and how this affects the stability of molecules in practical terms. When looking at diatomic molecules such as oxygen, O, nitrogen, N, or carbon monoxide, CO, molecular orbital theory provides a clear explanation of why they form bonds and how stable those bonds are. For example, nitrogen, N, has a bond order of 3, which is why the N molecule has a very strong, stable triple bond. Oxygen, O, however, has a bond order of 2, which indicates a double bond, and this makes the molecule less stable compared to nitrogen. This connection between bond order and stability is essential when we move on to larger molecules or ions. In molecules with more than 2 atoms, such as ozone, O, bond order and stability help predict how the atoms are arranged and how the bonds behave. The concept of bond order also helps us understand the nature of resonance structures. For example, in the case of the ozone molecule, there are delocalized electrons that can be represented in different resonance structures. The bond order of ozone can be averaged between these structures, indicating that the molecule's bonds are a blend of a single and a double bond. Now, let's take a look at the oxygen molecule, O. Oxygen has a total of 16 electrons, and when the atomic orbitals combine, the molecular orbitals are arranged in a specific order based on their energy levels. The bond order for oxygen is calculated to be 2, meaning it has a double bond. Interestingly, molecular orbital theory also explains why oxygen is paramagnetic. The presence of unpaired electrons in the antibonding orbitals leads to paramagnetism, which is confirmed by experimental evidence, such as its attraction to a magnetic field. For molecules such as nitrogen, N, molecular orbital theory predicts a bond order of 3, meaning it has a strong triple bond. This aligns with its known chemical properties, where nitrogen gas is highly stable and unreactive under normal conditions. On the other hand, for a molecule like helium, He, the bond order turns out to be 0, which is why a stable He molecule does not exist. So, in summary, molecular orbital theory gives us a deep understanding of chemical bonding by explaining how atomic orbitals combine to form molecular orbitals. It also helps us calculate bond order, which gives us a measure of bond strength and stability. The higher the bond order, the stronger and more stable the bond, and the lower the bond order, the less stable the molecule is. These concepts are essential not only for understanding molecular bonding but also for predicting molecular properties like magnetism and bond behavior in chemical reactions. Whether you are preparing for your Class 11 exams or working towards NEET or JEE, having a solid grasp of molecular orbital theory will help you understand the fundamental principles of chemistry. And as always, practice is key to mastering these concepts, so make sure to solve as many problems as possible and review different molecular structures. Thank you. We hope this video has helped clarify the complex yet fascinating topic of molecular orbital theory, bond order, and molecular stability. If you found this video useful, don't forget to like, share, and subscribe to Askprep for more in-depth lessons and tips on chemistry and other subjects. Keep studying, keep practicing, and good luck with your exams.